Okay. So, as Julia said, we've been trying to make this happen since the three of us, Luke and Julia and me, were in Luxembourg in September 2019, and we said, yeah, this is obvious. We've got to make this happen. So we picked May 2020, and then we picked something in 2021, and then something else in 2021. And then 2022 came, and we picked something there, and now it's 2023, and at last I'm in Chicago, which is really nice. In talking about the title, you may notice that there's this capital R point star spatial, and this is because this is a regular expression which parses both nothing or a hyphen. There are two R-Spatial orgs. One has a hyphen, one has nothing. So we're including both of them, although I work mostly in the R hyphen spatial rather than the R-Spatial with no hyphen or no space. So that it's addressing the most used packages in the R-Spatial package ecosystem. Now, one of the things which is happening, and I'll talk much more about this on Thursday, are changes in upstream free and open source software libraries. But that's for Thursday. So that if you haven't heard enough now, then Thursday is where to come for the complicated details. But what once we'd made the trip happen, then I asked, well, what shall I talk about? And I suggested some things, and of the list that I put up, the ones which got chosen were this one, and then the coordinate reference systems for the workshop, which is fine. But the main point of today's talk is to reflect on what do you do, or what can you do in a situation where software modules or packages are being maintained by a maintainer who may not be able to carry on maintaining the packages for a long time. So the choice was to look at what's known as the evolution project. We could have called it the dead end project, but that sounds a bit drastic. But it's what do you do when some packages have to be retired? So we could have called it retirement, we could have called it archiving, but evolution sounded more user-friendly, put it that way. So that's the intention. The summary, and I've run the slides past some of the people in the reference group that we have for the evolution project. They asked me to put in a summary up front for those who, having heard that, go away, and so that when we put it up on YouTube, then these are the take-home points which are put up front rather than at the end, so that people don't have to go through a whole YouTube hour in order to get to the take-home points. The take-home points are that the packages rgdal, and I pronounce it rgdal, but you can pronounce it rgdal if you like. RGEos and maptools, those three packages for which I'm the lead maintainer, will retire. They will be archived on the Comprehensive Archive Network, otherwise known as CRAN. During this year, 2023, we've been working on this since last year. We're actually now planning to pull the plug in October 2023. This gives the archive network time to the end of the year to sort out some of the casualties. We're not trying to cause casualties, but if people are not paying attention, there will be people whose workflows stop working. So that we have people from US government agencies, particularly in environmental matters, who are on our reference group and help a good deal, because their workflows built up 10 years ago on the old foundations now need to be moved to the newer foundations. So one reason for the decision is to reduce exposure to maintenance failure, but that's not the only reason. The other reason is to devote available development effort to the packages which are actually being developed rather than packages which are no longer being developed. Neither rgdal, rgeos, nor maptools are being developed. They're being protected from upstream changes in libraries, but no more than that. So that work is in order to keep the SP package workflows running, we're trying to replace calls out to rgdal and rgeos by calls to SF, which links to the same external libraries itself. And the maintainer of the raster package, Robert Hemans, has done, and there's another spelling mistake because he's Robert and not Robert. He's already moved, so we've been in contact with him for more than months, years, saying that this is likely to happen, and that the raster package, which depended directly on rgdal and rgeos, has now, since September, been moved to depend on the terra package, which is also written by Robert. So those are the take-home points. So if your workflows or your packages involve rgdal, rgeos, or maptools, then you have now some 8 months to get your act together. One of the things that we've also noticed is that the ecosystem has been evolving over time. So it's not just steps that we're taking to create movement, but some of them have been happening anyway. And I'm very pleased that Dirk can be with us, because without his work on the Rcpp package, then many of the improvements and dramatic improvements in maintainability for the packages Terra and SF would not have been possible. So that it's by leveraging work in the Rcpp package, which has made it much easier to interface C++ packages external to our upstream of RSpatial. In addition, those libraries have seen very rapid change over the last couple of years. A final point on the background is that at least since 2016, probably a couple of years before, Edsa Pepsmer and I have been discussing how we should protect users from maintenance failure. It's the maintainer falls under a bus problem, which maintainers need to consider in general. So that we've been thinking about how to do this for some time. Initially, it was to get SF in place, encourage Robert Hemans to move to Terra, and now complete during the rest of this year. So what is the evolving RSpatial package ecosystem? So if we go back a long time ago to the development of the SP package, and Julia was right, there was a meeting in Vienna in 2003 which brought together, created shared interests. In 2008, when the first edition of our book was published, then there were 12 R packages which depended strongly on the SP package. So we designed a package with classes that defined classes, and there were 12 other packages which used those classes. Most of those packages were written by us. So that GStat by Edsa Pepsmer and SPdep by me, and so that we were mostly writing classes and methods which we would find useful in our own work. 5 years later, the second edition came out, and we then distinguished between strong dependencies and most dependencies. Strong dependencies are when the code from the package on which you're depending is used unconditionally in the dependent package, so that for the dependent package to function, the upstream package has to be present in some form or other. It may be an old version, but it has to be present. The most dependencies are when you extend the group of strong dependencies, depends, imports, linking to include suggests. And suggests can simply be uses in examples, in documentation, but you can always jump over them, so that if, say, one of the packages is not present, then you jump over that example. So a most dependent dependency is broader than a strong dependency. In 2013, the strong dependency count was 78, and the recursive most dependencies, that's crawling out across the dependency tree of all the packages on CRAN, was 507. A week ago, the most dependencies out of the almost 19,000 packages on CRAN, 16,500 packages depended in one way or other recursively on SP. This is a bit scary because if you start messing up 16,500 out of 19,000 packages, I'm sure that Dirk sympathizes with this, because if something happens in Rcpp, then there are lots of people who are going to be very uncomfortable. So that it's something which weighs on you as a package maintainer. Today, if you just take the non-recursive reverse dependencies, so that's one step, then SP has 610 most and 486 strong, which is still quite a lot. The new SF package, again from last week, had most 539 and strong 300, almost 400. But it's growing fast. So SF is growing fast. So if we look at the cluster of R-Spatial packages using their PageRank scores, so that which ones connect to which, then we can see that SP is still the most connected package, but SF is rapidly catching up. Raster is still there. Terra is not yet referenced by very many packages. And we can see, unfortunately, that the 3 packages which are going to be retired during this year still have quite a number of links in the graph of package dependencies. This is fairly volatile, so it changes over time. So we're hoping to see those bars shrink by the time we get to October. Yes.
This question is quite tangential to what you're specifically presenting, but I'm interested in that data itself. Is there like a comprehensive data set on the dependencies of GRAN?
If you go not to the GitHub link for the presentation, but if you go to the source GitHub repo, then you find the code in the source for the presentation.
That draws down all the dependencies.
Well, it's an example for this particular case, yes. Yeah. It's based on work done by, and I usually reference the person who did it, so that if you look at some of my linked papers, so in my 2021 paper in Journal of Geographical Systems, you'll find the link to the original blog, which explained how to do it.
Okay, thank you.
And I won't go there now, but okay. In 2016, the USAR meeting was in Stanford, and Hadley Wickham gave a keynote where he declared that what are known as list columns are tidy. This is the same kind of thing that you find in GeoPandas. Pandas have a rectangular structure, but in general, you'd expect the class of the columns, the fields in database speak, to be one of a character string or a real number, an integer, a date, time, something like this. But a list column then has a column where the elements of the column are objects which can be more complex. Hadley Wickham first had said, no, this gets away from the idea of tidiness, which is the key phrase which is used, because there's no way that an irregular list column is tidy. On the other hand, there's no way that you can deal with lakes on islands in lakes on islands in lakes on islands in a tidy way. So in general, dealing with in particular vector geometries, there's no tidy way of expressing them. You can do points tidily because usually there are either 2 or 3 coordinates, but anything more complex is And they have an attribute, which is the coordinate reference system. So we accommodated tidy workflows as well as base workflows, which we've always used, partly because of user demand. So there are quite a number of users who are not familiar with using R in the way it was written, but use it through tidy workflows. So that in Edsa's article in 2018, that's the sort of status of the SF package in 2017, which has then a geometry list column using the simple features specification. Now, why simple features? Now, what we'd found when we were writing the SP package was that unfortunately, we had, in particular, I had mostly come across people using Esri shapefiles, and Esri shapefiles are not simple features compliant because they don't encode the belongingness of interior rings to exterior rings. You get a collection of rings where you define a hole by changing its, it's either clockwise or anti-clockwise to define what is a hole and what's not a hole. But you don't know which exterior ring a particular interior ring belongs to unless you do a topological analysis and assign it to. So, but the SP package was written using the understanding of vector topology that shapefiles use, and subsequent to writing the package, we found out that actually we should have waited a little and gone for simple features, so that SF is doing catch up on simple features. But interfacing the GEOS library in the rgeos package, we found out very quickly that we had to fake simple features, so that when Colin Rundle was helping me, then we worked out that we could do it by adding a special invisible attribute to each of the polygon's objects to indicate which of the holes belong to which of the outer exterior rings, which interior rings belong to which exterior rings. But this wasn't a robust representation. It was a kludge. And if you can do it properly using the simple feature specification, it seemed to be much more sensible. But SF was always a moving target, so that in the work, if you follow Edsa Pepsma's publication record through the most of the last decade, you find that there are interesting things going on. So that one of them was the need for the proper handling of metric units. It's obvious in a coordinate reference system that you refer to the units, but you should be able to refer to the units in the columns, in the fields. Can you aggregate things so that if you're unioning polygons, should you also average, sum? What should you do to the values? That if you've got population counts, you can sum them. But if you've got rates, you can't sum them unless you can get back from the rates to the original counts, sum them and recalculate the rate. So that was a concern which he had and which came out in papers with Stasch and Schneider in 2014, 2016, then a paper on units. So that if you think of SF as a done deal, it isn't. The SF package is a platform for community development of ideas. So that one of them is to distinguish between planar and spherical representations. So that GEOS, for doing topological work, works planar and it doesn't work spherical. But the S2 library, or the S2 geometry library from Google, works spherical. Is S2, it's on the surface of a sphere, and R2 is on an infinite real plane. So use the S2. We still get questions about what do I do if I have data from Fiji, which crosses the date line. So that obviously, if you treat them planar, then part of Fiji is a very long way away from the other part of Fiji. Unless you're projecting first. So if you project first to planar, then you're okay. But if you're not projecting to planar, you're just playing with geographical coordinates, then Fiji becomes a problem. So, but on the sphere, it's fine. So the idea was that if you're going to do any kinds of, or look at topological predicates or do topological operations on vector data on the sphere, then you should use the S2 geometry library and not GEOS. S2 has some really fast indices. I mean, it comes from Google, so they do things like this. But it's a breaking change, so that we get quite a lot of GitHub issues for SF saying that my data don't work. And you say, well, okay, but are your data geographical? Is it a geographical coordinate reference system? Or is it projected? And they say, well, it's geographical. It's what came from the upstream data source. It's geographical. And they say, are you aware that you can turn on and off the S2 package? No. Try it. So when they turn it off, then the operation, which would work planar, because the data provider provided geometries which were planar valid, but which when they're spherical, they're not, because on a sphere, a straight line, there are very few straight lines on spheres, even on S2, which is on the surface of the sphere. And so you get slivers arising because lines which, so you have and this is typical in the US, you have a county boundary which is drawn along a parallel. But this, it's going to be a curved line, especially. But that's what we find very often is that someone says, "Well, there's a topological error, and what's wrong? The data were okay until 2 years ago or a year ago when S2 came in." Say, well, if you turn off S2, does it get better? They turn off S2 and it gets better because there's an awful lot of legacy data out there, which was only designed when GIS thought planar. And treating spherical data as planar is, Edsa is a professor of geoinformatics, so that the things which we can see here, metric units, meaningful aggregation, spherical representations, they're very close to his heart as a professor of geoinformatics. These are things which generate a lot of interesting discussion. Practically, it's a problem because if people have a workflow which worked before and now doesn't, then you need to be aware that the spherical is coming in. And there are changes coming through all the time. One of them is instead of treating each point as a point, to treat a collection of points as a matrix rather than each point as its own coordinates, simply because iterating over millions of points is costly in the same way that it would be in a GIS. SF provides the STARS package, and STARS is spatiotemporal arrays, data cubes, with access to the libraries. It doesn't have to have extra ones. And then there are other packages which have come in. SF Networks is a nice package, SF Time, SF Track, and now Cubble, which is not from Munster, but the other ones are mostly from Edsa's students and people he's been collaborating with. So that SF is really, really in place. Rcpp is, as I've mentioned, really key. And while the pre-RCPP interfaces to C++ code in rgdal and rgeos work to a certain extent, my C++ is very pre-CPP 11. So templates are something that okay, they're not for my head. I have other things I would prefer to do. Edsa has adapted the use of RCPP, I think, very cleanly, which makes the code in SF, which interfaces GEOS and GDAL, much cleaner and so much simpler to maintain. So that when I have hundreds of lines of code in SF, the code which you need is in tens of lines. It's partly because our GDAL is very old, and for each new release of GDAL, then it needed to condition something. For each release of GEOS, the rgeos package need to condition on things. So that Rcpp is a much better fit to interfacing the libraries, and Terra has also done this. And locally, the interfacing of GeoDar to R without Rcpp, I think, would have been really hard. But with Rcpp in place, then you have a in sort of US terms, it will be an interstate. So you have a really well-trodden path to getting things to work in a predictable way. So that Rcpp has really been a major enabling feature in moving forward. So the situation as of more or less now for SF is that when this was written, it only had strong dependencies from 275. It's now approaching 400, and then links to other R packages, which are in the yellow-orange boxes, and below the line are the external libraries which are used. This is again is a well-known picture. We've used it quite a lot. One of the upshots which I'll come back to is that we're now post ASDAR. ASDAR was the book from 2008, 2013, and we looked at doing a third edition and then said no, because there's so much development going on with SF, it's better to do a new book. So there's a new book which should be out in May and is available online, which I'll provide I'll show you where the links are when we get to it. One of the other issues is the provision of CRAN binaries for Windows and Mac OS statically linked. So which means that we work closely with the teams for Windows and for Mac OS, and both of those have had big road bumps recently. One is, are there any Windows users here? Is everybody Mac? And any Windows users? Okay. On Windows, there's a C runtime, and the C runtime is a library which enables other libraries to work with Windows. But Microsoft got tired about halfway through Windows 10. They got tired of having to have lots of different versions of the C runtime. So there are some are dated, some are for particular markets, and they deal, among other things, with the character sets. And you probably know about CP 1252, CP 1250 in the Czech Republic, then it'll be CP 1250. So it gets a bit of a pain. Cell phones, Macs, Unix use UTF-8, and so Microsoft said, well, we won't necessarily call it UTF-8, but we'll go for a universal C runtime. So that the whole of R and R packages had to be moved to the universal C runtime. They still work backwards. So they still work on older systems, but we're now future-proof with regard to Windows. Apple also does things which make us jump through hoops, like the M1, M2 processors, the ARM processors. So how do you make sure that you're getting similar results from one and the other? And again, it's something of a road bump. We think that we're more or less there, but then you get someone like Gilberto Camara who says, you haven't remembered to include open JPEG 2, which we need for Earth observation imagery. So we had to scramble and get it built for one or other of the architectures and so on. So there's a good deal of work doing that. But this protects us from having to tell people to use Conda or similar in environments, because for the bulk of the user community, we're providing them with binary packages which are statically built, statically linked, so that they don't need to worry about installing versions of upstream libraries. Now, these libraries have changed a good deal, and I'll go fairly quickly through this because it's not necessarily part of evolution as such, but provoked it. Of the three libraries, it's difficult to know which is more important. GDAL is more central, and GDAL itself depends on GEOS and PROJ. so that they've all been involved for some time. When we began, the libraries were slightly more disparate. In the very beginning, then GDAL was just for raster, and there was a separate library called OGR, which was for vector data. And then they were brought together some from GDAL too. They used shared drivers, but before that they had separate sets of drivers for raster and vector. So things have moved along at a tolerable pace in the upstream library environment. So that initially we were working in a world which looked like this, where we had GEOS and we had PROJ and we had GDAL, and then we had the shared metadata for projections from PROJ and GDAL. And GDAL had many other dependencies. When PROJ got to a certain stage, there appeared to develop a situation which was then seized and exploited more or less mercilessly from the point of view of the downstream users of the packages to force through modernizations. Modernizations happened. On Thursday, I'll be talking about what happened with PROJ, but there was what was known as a barn raising project, where PROJ had been a separate entity, GDAL was a separate entity, and then they were brought together so that from GDAL 3, then you needed to use PROJ equal to or greater than version 6. And those two were very tightly bound together, whereas previously they lived in their own slightly separate worlds. This meant that a lot of work had to be done around 2019, 2020, in packages which used GDAL and PROJ, and that would then be the rgdal package, which I then used to prototype things, which then went into SF, and Edsa worked from his side to see whether what I was doing made sense. So that what was then happening initially was that the lists of coordinate reference systems were moved from CVS text files to an SQLite database. So you've got an SQLite database. Does anybody know where else geographically or spatially oriented people would often meet an SQLite database? The GeoPackage format is based on SQLite databases. So it was something which was very much coming in at the time. So that the first change was to use a shared metadata representation. Jump over this and jump over this, because I'll be handling this again on Thursday. But the changes were so great that you couldn't depend on simply business as usual working. So that workflows with updated PROJ and GDAL wouldn't work the same as the legacy PROJ and GDAL. GEOS at about the same time introduced a new generation topology engine, which again is better, but doesn't necessarily give you the same results that you had before. So that the pre-barn raising R packages were rgeos, rgdal, and raster. SP and raster used rgeos and rgdal. Maptools is a separate category. Not so much, it was even before all of this, because it included a copy of the library needed to read shapefiles. So that I wrote a couple of papers. There's one paper in the Journal of Geographical Systems, another paper in Geographical Analysis from last year, and I pity anyone obliged to read them, because you can see that my head is completely inside this barn raising thing. So that going forward, using SF, because it now has all of the modern stuff, and the way Edsa and I thought of barn raising was that we were traveling between the USAR conference in 2019 in Toulouse, where we met Angela and things were moving fast, and a spatial statistics conference near Barcelona. So we were sitting in the train, and they had to change the gauge. As in France, there's standard gauge for trains, and when you get into Spain, some of the trains are broader gauge. So what we were saying is what we're actually doing with rgdal and SF is we're taking the wheels out from under people's workflows and putting in new gauge wheels, and we hope that none of the trains will derail. So we were trying to provide the same service, but with nothing else happening. But the chances are something like this is going to happen again. So that getting rgdal out of the way, because when we were on the train, we said we just have to finish this, because otherwise there isn't enough developer effort to carry on. So it gets in a way simpler, but the underlying free and open source software packages are one of the things which has been occupying us enormously. So that changes in R-Spatial have been driven partly by the need to accommodate standard representations, partly by the need to react to upstream changes in upstream libraries, and then in addition to that, to react to the need to reallocate, and in my case, deallocate maintainer effort. So we have the evolution project supported by the R consortium. So we have a project repo. Issues can be raised on the this is this one here. Issues can be raised there. We've published 2 blogs, one in April, which was the sort of opening the show, and then this one we did in the middle of December, which is slightly prior to what I'll be describing now. So that they describe some of the steps that we've taken so far, and there's more in our book. There's a short appendix in the book. Now this is the link to the sort of evolution section of appendix of the book. The book itself is on this link here, which I won't go to save time. But if you want to visit the book, which will be coming out in May in print, but if you want to visit the web version, that's where to find it. So our plan is to retire maptools, rgdal and rgeos during 2023, and changing SP to use SF under the hood. So SF workflows should continue. Retiring the packages means that maintenance will halt and the packages will be archived on the comprehensive R archive network, so that they won't be visible for download. People who still have them installed will have them, but when you update packages, those packages won't be updated. So the point at which we're now in R2.2, R2.3 will come out in April, R2.4 will come out in April 2024. So at that stage, then you're starting to get really quite old, so that there will be a version of rgdal for Windows, rgdal for Mac, for R4.3, but R4.4 there won't be. So that from April 2024, then that's probably it. The source code for the packages will remain on RForge, and perhaps I should mention that one of the reasons for not moving the RForge repositories to GitHub was simply to discourage contributions, because we knew already 5 years ago that we weren't going to develop these packages. There was no point attempting to engage with people on GitHub. So we're going to retain the spatial classes defined in SP, and we're going to try and shifting the chassis from rgdal, rgeos to SF in the SP package. Some of the tools in maptools, some of the functions in maptools may be moved to SP, and we have a number of open issues in the evolution project saying how to do that. We're already seeing a certain amount of movement. These are the these are recursive strong dependencies. And we've already see a dramatic fall in maptools recursive strong dependencies. For the direct strong, that's non-recursive, we're seeing some changes, so that they're all declining slightly. Maptools is declining, rgdal is declining, and rgeos is declining, but the declines in so if we project this forward, we're not going to get there by the end of 2023. So we need to do more to handle this. I think one of the reasons for maptools seeing that very positive recursive strong change was that maptools has a function which was used quite widely externally, particularly in the car package, for placing labels on points so that they didn't overlap. In ggplot world, it's called ggrepel, but this was something which was written a long time ago by someone called Tom Short, and he contributed it to maptools, and other people had used it, including John Fox in the car package, had used it, and other people had taken it. Car is a very well connected package, so that this is a companion for applied regression, accompanying John Fox's the editions of John Fox's book. We've modified the code from the second edition of Astar to run completely without rgdal, rgeos, and without maptools. And this is available on the website, so that it provides, and I'm going to write a blog showing how to step around the use of the old workflow functions and methods to get the same thing out. So that essentially, instead of using rgdal : read OGR open brackets close brackets open parentheses close parentheses, you'd use as open brackets st_read open brackets and the file details close brackets comma quotation marks spatial, so that you read as an SF object and then cast to an SP object. So that those kinds of things, so you in lots of kinds of workflows, it's not too complicated to do it. It's just a little bit awkward, because doing it just by find and replace is not always going to work, because some of the arguments are in different orders or have different names. But if you just search through an existing script to look for those, then it's not too difficult to get it up and running. In most cases, we're using coercion in the way that I described. Sometimes we can round trip it. Other times the round tripping doesn't work quite okay for some of the attributes of the objects. The way that this is done is by an internal option in the SP package called SP_evolute, or this is in using the options function in R itself, or in environmental variable. And as I described on Thursday, I've also introduced the possibility to turn on and off the evolution status internally within a running SP. The ones here, these ones and this one, have to be used. They were, go back up. I don't think I can mark this. They have to be used before the R session is instantiated, because they set up a global environmental variable, which is then read when the SP package is loaded into the running R. It takes 3 values. 0 is business as usual. So this is the sort of from July, the disaster zone. 1 is stop if rgdal or rgeos are needed and absent. And 2 is use SF instead of rgdal and rgeos, so that it's going to the adapted workflows until June 2023. I repeat this, until June 2023, and we haven't set a date whether it's the beginning of June or the end of June. The default value in SP is 0, business as usual. When we flip the switch, the default value will be 2. It will use SF, and some things may become unavailable. but we want to get people with SP workflows up to speed to start using these tools to identify points of pain. So that once SP drops its weak dependencies on the retiring packages, so that it suggests rgeos, rgdal, and maptools, they will be gone in June. Then we'll be able to see which functions actually use those, actually need their weak dependencies. And what we'll be doing is follow the way in which raster has done it, because raster shifted from needing rgeos and rgdal to needing terra. There was a period when it needed all three, and now it's switched from September. It's from raster 363. It just needs terra to do all of the work under the hood. The raster still depends on SP because it depends on inheriting from the classes defined in SP, but it doesn't use any of the external functionality which was available before. So a couple of internals. What we've been doing is running reverse dependency checks. During the pandemic, this got a bit awkward because I had to log into my desktop and run the reverse dependency checks on all of the cores there remotely, and sometimes the line dropped. But I bought a laptop at home, and so I've been running, so the poor little box gets run. So it runs reverse dependency checks. Running them on 4 out of 6 cores or 5 out of 6 cores takes 5-6 hours, something like that. But it's checking to see what gets broken. So that reverse dependency checks give us something. They give us some insight into what's going on. There's also a GitHub package called package Appy on the rlibs repository. So the package Appy is available. This is the link to it. And it provides the tools for analyzing which functions of, in our case, the retiring packages are used inside CRAN packages, which are analyzed. So you use the package Appy map package for each of the packages, and then aggregate the results to see which functions are used by which package. And sometimes it's a bit scary because the package count is in hundreds. So they run well off the screen around the roam and come back again. But we're making progress. So that this would give you a flavor. No, I won't go out to this, but if you're visiting this slide, then you can go out yourself. You can link from these live links here, and we've been using this directly. We're contacting package maintainers of packages with too long lists and saying, hey, we need your help. These were in particular the Ursa package and the Fiesta utils package. We haven't seen any response from Ursa, and we've had one response from Fiesta, which is the USDA Forest Service. So we're hoping that they'll be respondent, but they use internals inside rgdal. We were also taking deprecation steps so that from the most recent releases of rgdal, rgeos, and maptools, we're now deprecating commonly used functions. So using package Appy, we're finding out which functions get used a lot, and then we're simply putting a deprecation label on them, so that we hope that people actually do watch their output when they're doing work. Experience suggests that this isn't an assumption one can make happily, but at least we've warned them that something is going on. We can also get CRAN to turn on a switch, I believe, which makes a deprecation warning, which is not a real warning, into a real warning. And if it becomes a real warning, then they get warnings on their CRAN check results, but they don't do that yet. So we're using deprecation warnings, and the next SP release will also have deprecation warnings. One of the difficulties which arises is if people use unit testing and expect silent from running a command, then it's not silent. It's actually quite noisy. So if you do something like this now, rgdal : read OGR, then you get 1, 2, 3, 4, 5, 6, 7. Yeah, it's only 7 deprecation warnings. But we have to be noisy and impolite in this way, simply to draw people's attention to the fact that there is an alternative. If people then start putting this in suppressed warnings, then that's their problem. There's nothing we can do to help them. So don't do that. We've also used SPdep, recent release. SPdep is now free of rgdal and rgeos and maptools. I think it's free of all three. Yeah, so that since August 2022, it hasn't even suggested any of the retiring packages. So that people don't need to use any of them in their workflows. If the incoming objects say to poly2nb to create a graph of neighbors of polygon is an SP object, then it will be converted internally into an SF object, and SF and S2, if necessary, will be used for doing the work. And so the old workflows carry on working, but it does fully support newer workflows. So the SP can be used without SPdep can be used without reference to the retiring packages, but you can still carry on using the SP objects if you need to. When we ran reverse dependency checks for SP, there were 27 affected packages, and I emailed all of the maintainers. And I made it a really nice, polite. So I said, of course, your use of the retiring packages that I've maintained for many years has been a source of great satisfaction, but now it is time to move on. I didn't put it in capitals, but I tried to make it polite. But there wasn't a great deal of movement. The biggest change which occurred was the one with point labels that we moved it from maptools to car. So that we're trying to be so if there is low-hanging fruit, then we'll go for it. So that by the middle of December, so a month ago, there were 98 packages, mostly depending on SPdep, and none of them failed for SP evolution status 0. But of this lot, only the ones which are marked with stars didn't fail when using SF. So we still have a certain amount there to do. We're not quite sure. And there were new packages depending on SPdep which had appeared, and 2 of them, spatial regimes and Sun Geo, failed anyway. But one of them, GeoMerge, passed for the SP evolution status. Then, so you can see you're going through package after package, but SPdep had relatively few reverse dependencies. So I decided to go for using raster as a larger scale test bed, because from September, raster didn't need to have, or packages using raster didn't need to have any connection with rgdal or rgeos. So we said, okay, so we'll go for them. So that there were 482 most raster reverse dependencies. And we then looked at the set differences between the rgdal, rgeos map tools. So there were 248 most packages depending on raster, which depended on either rgdal or rgeos. There are a couple more which depend on map tools, but raster didn't use map tools, so that wasn't an obvious. So we only found that of these, more than half didn't use any of the functions directly in their own code from the retiring packages. The other ones were using them simply because if you imported raster or depended on raster, then because raster depended on rgdal and rgeos, then you added them to the list of suggests. So you added them to the most list. So we wrote to people saying how to do this. So that what we did was to raise 167 GitHub issues. That's fun. And the rest were emailed. So that the status from yesterday evening was that activity, that is either an email back or activity on the GitHub issue, which I would receive a notification about because I was the initiator of the issue, were 34% of the packages, and 36 of those using the retired packages in code. And of these 45%, almost half of the GitHub issues showed activity, but only 12% of those who didn't have a GitHub repo. So that suggests that for the economists in the room, this is a nudging project. Evolution is about nudging. How do you nudge people to do the right thing? The right thing is to get rid of their dependencies before it becomes critical and affects their workflows. So it's a nudging issue. And this finding is actually very interesting because it suggests that maintainers on GitHub, because they're getting notifications from GitHub that something is going on, then they're more likely to respond than people who just get an email, which maybe goes into junk anyway, or why do I need to bother about this? Only one of the packages had an email address which was now invalid, and they will be archived from CRAN anyway before very long. So by January the 12th, so in addition to looking at which ones have shown activity, a fair number, so 27, so 10%, which previously had most depended on rgdal and rgeos, they'd gone away. However, when I looked at this in more detail, it turned out that some of the packages had simply been archived on the archive network. So the fact that they no longer showed up was simply that they weren't in the graph anyway. So whether it was because of the activity of the evolution project or not, I don't know. So next steps, and these are the last two slides, or maybe three. There's a bibliography as well, which we don't need to go through. So at the end of last year, 452 CRAN packages most depended on the 3 retiring packages. Of these, 258 most depended on raster. This is now including maptools, which it wasn't in the previous analysis. So there's a split between those most depending on SP and not depending on SP, so they're using rgdal or rgeos or maptools for some other purpose. Some of them are using them because there's a data set, that kind of thing. And that we'd actually tried to sort out a long time ago using the SPdata package, which moved the data sets to a separate SPdata package. So one forthcoming blog will be to look at the conversion of the Asta code to run without the retiring packages. And that blog will also link to a wiki on the SF repository in GitHub, which shows the equivalents for the SP, rgdal, rgeos workflows and the SF workflow. So what function calls might you replace with function calls to SF? And the target remains full archiving by the end of October 2023. And switching SP to evolution status 2 during June 2023. And this is then for people who are looking at the presentation online later on. Since you're reading and seeing this, you've already started preparing for the changes, and we're very grateful for your care and attention. So carry on. If you have workflows and packages you maintain using the retiring packages, you need to take steps now. For instance, as the example that I gave a moment ago, replacing read OGR with stRead and then cast to an SP class. If your work does not involve the retiring packages directly, but the packages you use do so, you could try things out, and this is something which we've been doing systematically for months now, is to have, because the library path for R can contain multiple libraries, then you can have one library which just has the retiring packages and then take it out. So that when you're running Rspatial is looking for packages, then you immediately find out if your workflow has some hidden need to get hold of one of the retiring packages. But if they're there in the pool with all of the other ones, then it's difficult to see when. So whether you think that your workflow's cleaned out, but maybe some other package that you uses one of the retiring packages, or one of the packages you uses a package which uses a package which uses a retiring package. So whichever way it flows, then you need to be sure that then they're not visible. Do use the SP evolution status when running R command check, because this will give you a handle on whether you're simply able to run business as usual or whether you're ready for June. If you're ready for June, then it should run, whether it's 0, 1, or 2, it should run fine. And if you're using time to update your workflows and they were SP workflows, consider whether it isn't going to be easier to move them to SF anyway. And if you use raster workflows, consider whether you're not going to be saving yourself time in the future by migrating completely to Terra. The aftermatter is simply the bibliography. So that this is where we are at the moment. Okay, thank you.
So we have a little bit of time for questions.
Shall I leave the recording on?
Sure.
Yeah, okay. But I'll stop sharing my screen.
Okay.
Shall I?
Yeah, sounds good. So either online or in the room, any questions?
Maybe I should start. Roger, very interesting, very scary too, because I know, especially in spatial regression and spatial econometrics, the developers of the packages, to them, dealing with spatial data as such is an afterthought. It's a necessity. So many of them either have their own ways of dealing with spatial data, which are sometimes pretty bizarre, or they rely on SP. And I was wondering if you have a sense of how receptive that audience is to switching to SF, which is actually very straightforward for those types of packages.
Not directly, but what we're trying to do is to make sure that it's as easy as feasible. So we can't make it easier than it has to be, that there shouldn't be any difficulty. And by providing mechanisms within SP itself, so that if you don't want to rejig everything, then you can, and the idea for the next blog, which will take up this point, is what's the minimum effort way of keeping my workflow running, which would be use SF to read things in, use SF to do aggregation, things like that, and cast to SP for everything. But if they're using SPdep to generate the weights matrices, that's already SF compliant. So that if you read in with SF and cast to SP, and then go to poly to NB, you didn't need to do the casting because the SF object would have flowed through in just the same way. So that's something which I probably should note, and so that in the blog suggest that for SPdep that it's actually simpler than the trouble you think you're being put to, because at least one of the components you're using to create a weight subject is already in place. So that for the kinds of packages that Gianfranco is working on, it's not a problem. So that in exactly the same way that you could use an SP object as if it was a data frame. An SF object already is a data frame, so that things like model matrix all work in the way that anyone would expect them, that there should be no visible change at all. And that also applies to other areas like spatial epidemiology and spatial ecology, where we're trying to make it as simple as possible, so that the only things where there may be marginal differences will be that rgeos assumed a precision, because GEOS has a number of precision models. One of the precision models is to say that we multiply all of the coordinates by 1e to the 8, so that you make them all into and you make them into integers, so that when you're trying to find out whether a point is the same point, it's that point in that precision, so that you're gridding the data on a very, very fine grid. So that you're using that gridded integer precision, if you like, but for very large numbers. Whereas SF uses the double precision, so that it's not treating them as integers, so that a very small change. We've seen this a little in the different computers can read a GeoJSON differently depending on Intel's for computation have extended precision. ARM just has the 64 bits. So you see some differences coming out there, but they're trivial. I mean, they're right at the least significant digit area, but sometimes it leads to things not matching up, to getting a geometry error. But in general, it's typical. You ask me a question, you ask me to simplify things for everybody, and I get into talking about a corner case, which happens one times in 10 or 20,000. But we have to be careful about the corner cases. But for the blog, then I'll write in that the easiest way for most people is to try it out doing it the simple way. If that indicates that you need to devote more time and effort, then that's what you need to do. But that we're trying to create pathways which are as simple as possible.
Thank you so much. We're at time, so thank you very much again. And for those of you who joined late online, Roger is giving another talk on coordinate reference systems this Thursday from 10 to 11:30. So we're looking forward to seeing you again then. And for now, goodbye and have a good day.
Okay, and I'll shut down recording.
Yes, please.